Hello everyone. Today our group will talk about the project Instarest. Instarest is the machine learning model project that predicts Instagram's number of likes according to post upload time. Our presentation will proceed as shown in the table of content. Instagram is one of the famous social media platforms, and it contains diverse groups which try to get as much users' interest to promote their posts for diverse marketing purposes. To help diverse groups to maximize number of likes, our project aims to find the correlation between number of likes and upload time. Our project will also analyze behavior trends according to diverse cultural backgrounds such as Hong Kong and Korea. Our project name, Instarest, has been made as the combination of Instagram and interest. Interest represents users' likes in Instagram. Now let's move on to the data engineering part. We have 12 groups of data: big companies with Instagram account, influencers, celebrities, Instagram shops, and Instagram advertisement companies on the theme of food, travel, and beauty fashion. Each category has Hong Kong and Korean subcategories. Each subcategory contains 10 accounts, and each account contains 50 datasets. Therefore, we have a total of 6,000 records. We have collected datasets with InstaTouch Scraper, and we have collected many types of data. However, we will mainly focus on the number of likes, timestamp, number of followers datasets.
Thank you, Jimin. Now let's talk about the machine learning model that we implemented. We established our model using TensorFlow 2.0 Keras sequential model. We implemented 9 dense layers after passing a normalization layer. In each layer, we implemented an L2 regularizer and dropout layers in between each dense layer. We used ReLU as activation function, mean absolute error as loss function, and RMS prop as optimizer of the model. Let us now take a look at the demonstration at Google Colab. Firstly, we import some libraries that we use in the model, like Pandas and TensorFlow. We are using TensorFlow 2.4.1. We also import all files from the Google Drive. Now, we read the directories of files into a list, and read all files into a Pandas data frame. We combine all data frames to form our large dataset, which is named raw dataset. We can see that the raw dataset consists of 6,000 rows with 25 columns. Next, we process the percentage of likes per subscriber data by dividing the number of likes by the number of subscribers. We also divide the timestamp to extract hour and weekday as the new columns. Now we only have 12 columns in the dataset. Here we applied one-hot encoding to the column's type and category. We changed the column its video from Boolean to integer 0 or 1, and changed all data type as floating point. We applied a 70-30 split of training and testing data. We also popped the percentage of likes per subscribers as our data label to be predicted. Here we can see the dataset of training and testing features. There are 4,200 rows of training data and 1,800 rows of testing data. We designed our Keras sequential model as follows. We adopted a validation split of 30% of training dataset, with shuffling at each epoch. Number of epochs is set to be 1,000, with an early dropping policy of 300 epoch patients. We save the last number of epochs run on the training process in a variable. We fast forward the training process. The testing data shows a testing loss of 1.53, which implies 1.53% mean absolute error. 1,000 epochs are run, and no early dropping occurs. We can generate a training and validation loss graph for evaluation use, and a CSV of the prediction details that help evaluation process. Now, let's make some evaluation to our model performance. As a general evaluation remark, the prediction on percentage of likes has a testing loss of 1.43% during the evaluation stage. Among all 12 categories of Instagram accounts, the mean of percentage difference is contained between 0.5% to 3%. From the training and validation curve, we can verify that no overfitting or underfitting problem exists in this model. Since the main objective of the model is to find the optimal uploading time of Instagram posts to maximize the number of likes, we found out a mismatch of predicting the trend of good or bad uploading time. In this graph, the horizontal axis is the hour of a day, and the vertical axis is the mean difference in percentage of likes. Gray and yellow bars are the real result of uploading time, while blue and orange bars are the predictions. For example, we expect the tallest yellow bars should have the tallest orange bars, which implies that the prediction knows what time would be the optimal uploading hour. However, the model is not predicting trends well for all 12 categories. In the second analysis, we modified the model to split timestamp into hour, minute, and seconds as the data features. While the testing loss did not improve nor worsen, the model still cannot predict trends well. We added a new data feature, weekday, that is also derived from timestamp, and trained the model again. We can see rough trend predicting effort in two categories, big companies in Korea and IG shops in Korea. In the fourth analysis, we tried to simplify the model by removing several data features from the model. We also decided to combine all weekdays in the evaluation, while still including weekday as a data feature in the model. We also need to pay some optimization effort to lower the testing loss in the next version of the model. In our last analysis, we found out a 70-30 split of training and testing data would minimize the testing loss. To conclude, three categories show the ability to predict trends of optimal uploading hours, which includes celebrity in Korea, IG shops in Korea, and beauty and fashion in Korea. We also ran additional analysis on the optimal strategies for these categories of Instagram accounts to maximize their number of likes. The results are as follows: 3 p.m., 9 p.m., and 12 a.m. on Thursday, Friday, and Saturday, uploading swipeable carousel for Korean celebrities. 9 p.m. to 12 a.m. during weekends, uploading single image for IG shops in Korea, and 1 a.m., 8 a.m., and 10 p.m. on Sunday for beauty and fashions in Korea. In general, photos are more favorable than videos. Single image and sidecar are also more favorable than single video.
Thank you, Jack. While the model is performing well in three categories, there are certain limitations that we face in the project. Our first limitation is on data collection on image classification. We have used a PIP package called Instagram Scraper. There were problems with limitation of scraping post numbers as 50 on the PIP package and Instagram blocking on our accounts when scraping. We have used alternative accounts to scrape the data and switched to VPN. However, our method was not enough. For future solution, our project needs cookies, session ID, and alternative PIP package that could support more scrape per account. Our second limitation is post-upload time prediction trend. As shown in our table, our current problem is that we only have 3 Korean categories that can predict post-upload time and don't have any Hong Kong categories that can predict post-upload time trend. This is the end of our presentation, and thank you for listening.